Hi guys, today we're going to have a look at Java generation or Java garbage collection and the generations associated with Java heap. Java heap is divided into three spaces. We have young space, old space or tenured, and meta space. Meta space is where classes and methods and various information about the runtime that Java environment are loaded. They're also loaded into native memory since Java 8. And in this tutorial, or more of a lecture type tutorial, we're going to have a look. We're going to look at young and old generations. So the young generation is where objects are created, or to be more precise, they are created in the Eden space, which is part of young generation. Then we have survivor space 1 and survivor space 2. Those are usually smaller than Eden, but it depends on the configuration. In fact, most of the stuff related to Java garbage collection is sort of dependent on the configuration that you set to JVM. And also, various JVMs will have different garbage collection mechanisms. So here I've got an app that simulates sort of simplified version of garbage collection. So we got a button that creates new object, and new objects are always created in the Eden space. My Eden space is it can contain maximum of 10 objects, but typically the space, the size of Eden space is configured in bytes instead of number of objects because different object will have different size. And similar survivor space 1 and 2 in a similar way they are defined in megabytes or rather bytes in rather than actual numbers. So once you create an object, it gets created in Eden space, and it will have a sort of age counter of 0. The age or maturity of an object allows garbage collection to know when exactly the object needs to be promoted to the tenured generation. And this allows garbage collection to easily remove all of the newly born objects if they're short-lived. And the advantage of that is because young space is cleared very fast as opposed to tenured generation collection, because typically tenured generation is larger in size, and also when garbage collection happens, the space is going to be compacted. So the algorithm is slightly different, and the cost is a lot higher in terms of CPU load. Although it could be run in parallel, and then you wouldn't really notice the difference. But this is how it goes in sort of generally. Then, as they mature, and the maturity increases by 1 when minor GC happens. And minor GC is triggered when Eden is full. So if I keep creating objects, let's remove some of them. So this button basically randomly marks new objects dead. So basically, there are no strong references to those objects. Then, when we perform minor GC, those objects that are surviving or they're live, they get moved to survivor space 1, because from the start, both of the survivor spaces are empty. And Eden gets cleared. So their maturity level increased by 1, and now Eden is empty again, so we can create new objects. Minor GC happens exactly at the time when there is no space for a new object to be to be given to that object basically. So we have 4, 9, 10. So I press this again, minor GC is going to occur because there are no more spaces to allocate to the object. And instead of moving to S1, because we already had S1 filled with some objects, on the next sweep it moves to S2. Um, if survivor space is full, anything overflowing, any objects that overflow that space, will be pushed directly to the tenured generation, irrespective of their maturity level. And this is why you don't set your survivor space too low, because it might be the case that an object, even though short-lived, it moves to the old space, which we don't want, because old space doesn't get cleared until it's full or until major GC is triggered. So what we're going to see is if I manage to kill all of the old space objects, or at least some of them. So yeah, those are now dead, those red ones, but they still occupy memory, and they're placed, since they're in the old generation space, they will still be present even if minor GC occurs. So the old space is still contains those two objects which are technically dead. And this is something you want to avoid if possible. So we can create more objects and kill randomly some of them. And so I set the age threshold for promotion. This is the term that is used to say that one object gets promoted to the old generation. So if that particular object that says 3 survives, then it will be moved on next sweep to the old generation. So there we go. We have now the object that was in S2 but got moved to the old space because his maturity level reached, or its maturity level reached level 4. And yeah, that is pretty much it for the young generation. Major GC occurs when the old generation gets full. So I currently have its size set to 25. So I basically need to create 25 objects in there so that the major GC will occur. There we go. That was the major GC that cleared some of the objects in the old generation. And if major garbage collection does not clear the objects in the old generation, then this is the case where you have your out of memory error that is raised by JVM, essentially saying that there is no more memory to be allocated because all the heap is full. So there you go. It prints out of memory error because, well, technically that couldn't occur because there was no space to allocate. But when Eden gets full and all the survivor spaces get full, and then we try to push an object to the old generation because minor generation couldn't clear them, and then major generation or major GC couldn't clear them, in which case that out of memory error will be raised, and JVM is likely to shut down. And this is the sort of very high level overview of how garbage collection is done in Java, or in Java 8 in particular. But again, these things will differ based on JVM vendor and the configuration that you set. Thanks for watching.